Hi, welcome to 5.3 on solving quadratic equations by completing the square. So the first question asks if you remember perfect square trinomials, and we didn't really talk about those last semester, but perfect square trinomials look like this. So if I have something like x plus 4 squared, and then I were to write that in standard form, I would get x squared, and I would be doing x times 4, so that's 4x plus x times 4, 4x plus 4 times 4 would be 16, because it would look like this. And so then when I simplify that, it would be x squared plus 8x plus 16. So the idea we're looking at here is that if I have this 4, if I double the 4, that's my b, or my coefficient of x. If I square my 4, that's my c or my constant. And so right here, we're just noticing what happens. The constant here is 9, and the coefficient of x is 6. And then how do we get from the constant to the coefficient? We square root our constant, so square root of 9 would be 3, and then double it. And then same thing here. Our constant would be 36, and then our coefficient would be negative 12. And to get from here to here, on this one we would square root it, but we would use the negative version. So we take the negative square root, and then we double. Same thing, except on this one we're going backwards. So our coefficient of x would be 6, constant would be 9. We would divide by 2, then square, and here our coefficient of x would be negative 12, constant's 36, negative 12 divided by 2 is 6, and then 6 squared is 36. So divide by 2, then square. Okay, so that's just a pattern we're noticing. Now we're going to talk about how that can help us to find out some things about our quadratic, to factor it, basically. So we can basically make our quadratic equation into something that is helpful for us, make it into that pattern or that perfect square. So what we do is we take whatever our b term is, and we take half of it, and then we square it, and then we're going to add it to this part of our equation. So for example, on this one, I would take 24 and divide it by 2, and I get 12, and then I take that 12 and square it, and I would get 144. So I can rewrite this as x squared plus 24x plus 144, and I could rewrite that as x plus 12 squared. And if I were to actually multiply this out, it would end up being this. So if you're confused as to how this is becoming this, maybe try it backwards, multiply it out, and see how you get this. Okay, let's do one more. So let's do this one. So this one right here, if I take my 5 and divide it by 2, I get 2.5. And then if I take that 2.5 and square it, I get 6.25. And so then I would write x squared plus 5x plus 6.25, and I could rewrite that as x minus, x plus 2.5 squared. Those are the same thing. Okay, you try the next two, and then take a look at the answers I've got here. So that's our c term, and then that's how it's factored. That's the c term. That's how it's factored right there. Okay, so let's take a look at how we can use that to complete the square. So these are your steps. You can refer back to those later. I'm going to actually take you through the steps down here. So the first thing we're going to do is we are going to kind of clear out this side over here so it leaves it blank to add whatever we want to make that perfect square. So I'm going to subtract 12 from each side, and I've got x squared minus 6x, and then I'm going to leave a space for whatever I need to complete my square. And then over here, 19 minus 12 is 7. Okay, so now we decide what it is we want to add here. So this is my b term. If I take the -6 and divide it by 2, I get -3, and then -3 squared is 9. So what I want to do is I want to add 9 over here, and that's completing the square. But if I add 9 to the left side, I have to add 9 to the right side. And so now I have x squared minus 6x plus 9 equals 16. And now I can rewrite this in factored form. So that's going to be x minus 3 squared equals 16. Now I can use my, I can square root each side because they're both perfect squares. Now, this one is not always going to be a perfect square. It's just a nice, pretty problem to start out. So we're going to square root both sides. This side gives us x minus 3, and this side is plus or minus square root of 16, which is 4. So now I have x minus 3 equals either positive 4 or x minus 3 equals negative 4. If I add 3 to both sides over here, that gives me x equals 7. And then if I do add 3 over here, then x equals -1. Okay, and then those are our two possible solutions for that one. So go ahead and try the other problem over here. Oops, you can't see the bottom. There you go. So 7 and -1. And then try the second problem. Come back and look at the answer when you're done. Okay, there's your answer for the second problem. Okay, let's try one where we have a coefficient of x squared. So we'll do this one first. It's very slightly more difficult, so we'll do this one together and let you do that one by yourself. So first thing, I'm noticing that there's something in front of x squared, which means I want to divide everything by 5. I'm noticing that not everything is divisible by 5, so I'm going to clear this space out and see if I can fix that. Sometimes you can, sometimes you can't. And then over here, 61 minus 6 is 55. So on this one, it is nicely going to divide by 5, so we can make a nice pretty problem to work with. And so -50 divided by 5 is -10x. I'm going to leave my space because I'm going to complete the square. So I take my -10 divided by 2 and I get -5. Squared is 25. So I'm going to add 25 to both sides because that's completing my square. So now I have x squared minus 10x plus 25 equals 36. I can rewrite my left side as x minus 5 squared equals 36. And then I can square root both sides. And so I have x minus 5 equals plus or minus 6, which gives me x minus 5, either positive 6 or x minus 5 is -6. This side gives me x equals 11, and this side gives me x equals -1. So those are my two answers for this one. You go ahead and try this one, and then come back and check your answer. That's what it looks like. That's not written very well, but it's a 3. And the one at the bottom here, this involves a graphing calculator, but it is interesting to think about advantages and disadvantages of different ways to solve. So we are going to work on that one in class with our graphing calculators as a warm-up next class. Okay, let's look at one more thing. We're going to do an application problem. So in this one, we've got one where we're shooting something in a parabolic arc again. So we're launching a water bottle rocket from a rooftop given by the equation h equals -16t squared plus 320t plus 32. T is the time in seconds. We want to know how long it will take to return to the ground. So that means our h is going to be 0. So we've got h equals negative 16 t squared plus 320t plus 32. Now I want this to be a 1, so I'm going to divide everything by negative 16, and on this one, it's a nice pretty problem, so everything's going to divide evenly, but that won't always be the case. So this is 0, t squared, 320 divided by negative 16 is negative 20, t, and then 32 divided by negative 16 is negative 2. I'm going to clear out this space so I can complete my square. Okay, so I've got my space here. I'm looking at my b term, it's negative 20. I divide that by 2 and get negative 10, square it, and I get positive 100. I'm going to add 100 to both sides. I'm running out of room, so I'm going to go up here. So I've got 102 equals t squared minus 20t plus 100. I can rewrite this as t minus 10 squared. I'm going to square root both sides. Okay, I already messed around with 102 a little bit, and it cannot be simplified at all. So we're just going to rewrite that as positive or negative square root of 102 equals t minus 10, and then I would add 10 to both sides. So I've got 10 plus the square root of 102 and 10 minus the square root of 102. And I put that in my calculator. I get 20.1 seconds, and I get negative 0.1 seconds. I can't have negative seconds, so 20.1 seconds is the only one that makes any sense in this situation. Okay, please mark down anything that you had questions on, and we can talk about it in class next time.